I've done it. Did you see a message about the thing being recorded? Yep. Okay.
Yeah. Yes.
Okay, we should do a brief introduction. You want to go first, Jen?
Sure, I'm Jen Carter, and I'm a learning coordinator for Vernon School District, SD22. I'm a grades 4 to 12 coordinator right now, but my past experience, I was like a K to 3 teacher for many years, and I'm the vice president of the BCMT. And I'm here from the traditional unceded territory of the Silk Okanagan people, and it's a beautiful day here.
And I'm Sue Robinson. I am a district numeracy coordinator in the Gulf Islands School District. So I am here speaking from the unceded and ancestral territory of the Siwat, Wasanich, and Cowichan nations. And it's a pretty nice day here as well. So I am surrounded by ocean and take advantage by heading into the ocean as often as possible. While I am working K to 12 as a numeracy coordinator, most of my teaching has been at the high school level. But I've also worked extensively with teachers from primary and intermediate levels as well. So we're gonna get rolling here with our webinar because we're hoping that it's gonna last about an hour.
Mm-hmm.
And so I remembered to record the session, so that's good. And we just
I'm going to go, you talk, I'll be right back in 1 second.
we just wanted to start with this quote from the Bruce Flynn and Yearly book, Rethinking Fractions, which is where we started on our journey here for this particular presentation. And this idea that if we can use a limited but targeted set of representations, we're really going to help students develop a solid understanding both of these models and how to use them to help with their understanding. I know that if my grade 9 students all show up having used these models throughout their math education, they're going to be able to make use of these to support further learning. So none of these models kind of end. The area model is a really great way to introduce algebraic thinking and operations on polynomial expressions. And it's something that I would still use in a grade 11 or 12 class. And so really just the more that we all make use of these representations as students move along their math education path, the more the students can make use of these to support their understanding. If you wanted to
and I would say for elementary, we really want to be teaching conceptually, and the way that we do that is when kids have visuals or context, or not just the symbolic piece, which we often jump to far too quickly.
And speaking of that, when we look at the curriculum, if we look at our BC math curricular competencies, I'm just highlighting one particular strand of those curricular competencies, communicating and representing. And so the first blurb that pops up is from the grade 1 curriculum document, and then we've got the grade 7 curriculum document, and we've got the grade one from a grade 12 course. I don't remember which course exactly I pulled this from, but you can see as you look across that these are the same, K to 12. And the one that we're really focusing on here today is this idea that we can represent mathematical ideas in concrete, pictorial, and symbolic forms. It's not an or here. And so even like at the high school level, this is still like we want to be making use of all 3 of these forms in order to help develop student understanding. And I think this is really important that we break down some of the assumed hierarchy of mathematics, that the symbolic is the goal, that if students can understand the symbolic, that they've hit the end, the pinnacle, that's as far as they need to go. But I know from my experience with students and their dealings, particularly with fractions, that they often in grade 12 have an understanding of the procedures involved, and they can multiply and divide fractions symbolically without having any understanding of what they're actually doing or what the operations represent. And so really important that we are all from K through 12 dealing in these concrete pictorial and symbolic forms. You good, Jen?
Yeah.
Okay.
I don't think I can advance the slides.
I got that.
So just when talking about models and visuals and things, something that really stood out for me when I read Kathy Bruce's book on fractions was this idea that we hold on to representations that we're initially exposed to, and draw from that initial visual experience. And so we need to be mindful of the models that we are, I hate to say providing to kids, because I'm a real believer that kids should be getting and like using what makes sense for themselves, but we want to be mindful of the models that we're using and when we're using them, because for instance, circles are not that easy to partition. And I walk into schools many times and see great work that's being done, but with the misconception that like without the understanding that fractions are equal partitions. And when it's the circle model, it just reinforces to kids, like, because they can't equal partition as a circle very easily, then they start developing that misconception about equal parts. So we're going to be talking about different models today, and Sue's going to talk about some of this.
Yeah. Well, and we just wanted to come back to this, these 8 core concepts, coming from the Rethinking Fractions 8 core concepts to support assessment and learning book. That really is a lot of like the starting point for a lot of Jen and my conversations, but which have branched off into other directions as well. And so, looking at these core concepts, hopefully as we go through some of these models, we'll see, or some of the tasks and examples that we've pulled together today, you're going to be able to see, oh, right, here's an example of something that would allow students to partition unit fractions into smaller unit fractions, or to compare fractions in a variety of, using a variety of strategies, that we don't only need to teach comparing of fractions by coming back to this idea of common denominators, but there's actually lots of other ways that we can be comparing fractions, and that we really want to give students the ability to make choices from flexible strategies from an early age, and so that they carry on throughout. So we just sort of wanted to remind you of these really nice core concepts that I feel at least can really help kind of guide you in your fraction work in your classes.
Yeah, so we're going to start out with the set model this morning, and this one is actually very interesting because I remember reading from Beyond Pizzas and Pies, that book. They talked about how the set model is often missed when in the beginnings of teaching about fractions. And in my district, we have numeracy screeners, and we check, one of the diagnostics is to check to see if students have an understanding of, actually they're identifying 1/4, and very rarely do kids identify 1/4 in a set model. So it helps guide teachers in what they need to be, like those experiences that they need to be providing in the classroom. It's weird that we can't see our notes here. So with the set model, this is the idea that the collection is the whole, and that each item or a subset of the collection is or each subset represents the fraction of the whole. So if we're looking at the whole as 8, and we can see 5 pink circles, so that 5 is part of the whole of 8. And it's important for kids there's a lot of work that needs to be done around the idea of set model, which I'm going to talk about here for the next little bit. It's
Okay.
weird not to be able to advance.
Yeah. You ready?
Yeah, there we go. And so what I'm going to be sharing about the set model, a lot of it comes from Marion Small's book, Uncomplicating Fractions. If you've seen this one before, this is one of my favorite resources that I use as a learning coordinator in numeracy. I love it because she talks about that continuum of development from K to, it says grade 7, but this is Common Core, so grade 8. And one point that she makes in talking about fractions at like grade 3, 4 level is that kids often think that like a set model or items need to be next to each other to be able to describe the fraction. So for instance, on the left-hand side, oh no, sorry, that's not this one. I'm messed up today, excuse me. Well, there's two things. They need to be beside each other and that they have to be the same size. And this is an example where kids will often think that because the one star is larger, that they would not identify the white as one of 3. They would probably say one of 2.
I'm going to go to the
And
next.
in our next session, we're going to be talking more about assessment and those misconceptions that come up. But that's just something to keep in mind, to provide experiences where a set doesn't have to be all exactly equal things. And in the set model, this is where things can be of different sizes, but we have to be explicit about what the things are that we're talking about when we use fractions to describe that, if that makes sense.
Oh,
And then the second, oh yeah.
what happened? Oh, I think we just forgot what order we're going in here. That's okay.
Oh, okay. No, that's good. The second thing that that she talks about is how in a set model, especially when we're using like counters or squares, or in this situation where we have rectangles that are connected together, like let's say unifix cubes or something like that, that idea of students understanding that 1/5 is like we're copying it to get to 3/5, or if all of them were filled in blue, then that 1/5 is being copied 5 times. Kathy Bruce talks about counting by unit fractions, but Marion Small talks about like them being copied. So I'll let you advance to the next one. This was the point where they don't have to be side by side, like in that last visual. We can still talk about 3/5, even though the collection is scattered. And on our diagnostic that I was speaking about earlier, it is a scatter. And so kids, just for some reason, they don't see that 1/4 in that scatter.
And just before we move on, I want a little plug for Marion Small. I mean, her books are amazing, and I use, there's about 3 or 4 that I use quite often just to be like to do some research. And all of her books, she has such excellent tasks, and they're all just embedded like within like, you know, whether it's a book just specifically about tasks or if it's a book about bigger ideas, she's always got these really great tasks embedded within whatever she's doing. And she's one of our featured speakers at our fall conference in October. And she's so generous. She's going to do 3 presentations and she's going to speak at the Math Happy Hour. So we're really excited to have Marianne Small with us in October at our conference. And I'm hopeful that I can find some time to sit in on some of her sessions.
She's amazing. Yeah.
Yeah.
Okay. So the next point that I thought was important for us to understand was this idea that when we're thinking about sets, not only would let's say for instance 1 diamond of 5 be 1/5 of the set, or 3 purple diamonds are 3/5 of the set. But if you can just click to the next one, then hopefully it, whoops, yeah, there we go. So we also want students to understand that they can think of a group or a subset as one. So for instance, if we're thinking about the first column of the purple diamonds, we could circle that and think of that as one part of 15. And so when kids understand that, then they're able to understand that if there are 15 copies or diamonds, like we see here, and 1/5 of each of the 5 copies makes a whole, then there are 3 wholes, right? And then she talks about later on in the grades, that understanding also helps students better understand why 3/5 times 2 is 3 times as much as 1/5 times 2. Does that make sense? Do you want to add anything to that since you do more of the operations types of things?
No, I think that was good.
No? Yeah. Okay. The other thing that she talks about is that often we'll see, like, for instance, if we do paper folding or examples in books or worksheets or whatever that kids are doing, we might see the 5 squares pushed up against each other. And she talks about how it's really important for kids to do that action of separating and then that counting. And in choral counting and counting collections, they talk about counting by counting fractions, and Kathy Bruce talks about counting by unit fractions. And so in the earlier years, we want kids to physically do that, whether they're maybe cutting it up into 5 pieces and seeing that that's 1 of 5, 2 of 5, or each one is 1 of 5, but then when we put them together, we can make 2 of 5, 3 of 5. But then she also talks about and Sue will talk more about number lines, when we're moving over to number lines, we need students to understand that it's that space from 0 to 1 that represents 1/5. And I see this all the time when kids are counting whole numbers in the early years. Often they will have their finger on the 0 and they will count that as 1, 2, 3, and they're not seeing the space as one whole. Somebody asked about sharing the resources. The fraction one, I think, is at the end on one of our slides, but we can share the others as well. So yeah, just helping kids make that connection of one piece and seeing that on the number line as one section. And she talks about how that's really important for early measurement concepts as well.
I had to figure out where my mouse is to get it to the next one.
And so the next thing that stood out to me was that it's helpful if we provide kids with partitioned shapes as models for them to place the counters onto, to help them start to gain that understanding of, for instance, 3 things are one part or one subset of 3. And so things like 10 frames, egg cups we've used before. Sue, if you can go on to the next slide. This is an example where it is helpful to use a circle model. When kids have 10 counters, so they've distributed evenly 3 in each section, but they're like, oh, what do I do with this one more? And they often know that they need to share that extra one, but some kids can't think about how much to share by, and so they can place it on a model like this and easily see that each part gets 1/3 of that leftover. And so just providing tools and just, I think, a range of materials for kids to go and get to help them think about or think with is really important. And so, like Sue talked about tasks, Marion Small is known for her open questions. And I love using open questions with kids because it really does help to reveal what they understand and don't understand. These are just some examples that came directly from this book. And another book that I love is by Peter Sullivan. I think it's called Open Questions for Math Thinking or something like that. It's purple. I can add that to the link, but it will have a section in there. There's one for grades K to 5, and then another one, I think, for grades 6 to 9. But really great, simple questions. And what I used to do with these, my kids had a math journal, and I would just kind of type out one of the questions onto strips or cut into strips of paper, and they would glue the question at the top of their journal page. And with a lot of these, the answers can be endless, so they can fill a page with their thinking. So that's an idea for some tasks for sets. And I've been working in a lot of classrooms here in Vernon around fraction concepts. And one thing that I often do just to help teachers see the importance of flexibility of materials is just to bring in a basket of materials that kids can choose from to represent fractions that they are comfortable with and in different ways. And so, you know, things like ribbon and paper and counters and stickers and Play-Doh. And there was Play-Doh in that basket, but kids don't necessarily always grab Play-Doh right away. Like they love the idea of choice. It gives them agency. And then we just let them write on their desk what the symbolic representation is of their visual that they created. The second image, this student was like just in the beginning understandings about fractions. And so this student did choose Play-Doh, and they were just working with what 1/4 means. And then this teacher and I could walk around the classroom and just have quick little conversations to nudge their thinking along. Quick little 30-second mini lessons, really. And because it's visual for us, it helps us really be able to see what next. And then just on materials, again, another activity that I did last year in a grade 5-6 classroom, we were heading towards equivalent fractions. And so we used this old story, the Hershey's Milk Chocolate Fractions book. I hyperlinked it to the online YouTube video and reading of it. And so we just projected it and listened to the story, and the kids followed along with Play-Doh and just modeled what was happening in the story with Play-Doh at their desks. And super, super powerful for them to begin to get that understanding of subsets and equivalent fractions.
Okay, we're going to move on to another model, but Jen's still going to keep talking for a little bit.
Oh, well, Sue is super excited to talk about Cuisinart rods because she spent time over spring break just learning all things about them. I've been using them in classrooms for a while. I remember being really intimidated by Cuisinart rods when I was in the classroom. And then when I got into this role about 10 years ago, I thought, all right, I need to figure out what these things are all about and start using them. And oh my goodness, now I just bring them in. I actually literally bring them into classrooms and leave them behind because they're just so powerful. Something that is powerful with them is that when kids start gaining the understanding, for instance, on the top row, that idea of what 1/3 means, it actually means 1 of 3. And I talk with kids about how the symbols in math can like represent words. And so that idea of 1 of how many in the whole set is really helpful for them. And then the other part of this is that they can see that 1/3 is actually larger than 1/4, which is a common misconception because they know 4 is larger than 3, but they can see the smaller parts or the smaller blocks when thinking about quarters versus thirds.
And then you can use smaller pieces to make up these larger pieces, and this can lead into some operations on fractions. So here we could add 2/3 plus 3/4 if we can figure out that, oh, we can use these little 12ths blocks to match up for both the thirds and the quarters. Then we can string out a whole series of 12ths, count them up, and then we know that 2/3 plus 3/4 equals 17 12ths. And so that gives, and this is something we can be doing before we introduce really operations on fractions, as really like just really introductory ideas of comparing the fractions and putting them together or taking pieces apart. That just because students don't officially or formally see addition of fractions until the 8th grade, they can still be doing this informally much easier as you're playing with these materials. So these are fraction bars that I pulled off of Polypad. So for a lot of the images that follow, I've used, and some of the ones that were previous, we've used Polypad as a way to create the images. There's a link to Polypad at the end. And so we're gonna just do a quick little, what do you notice? So might be nice to, throw some things in the chat here. I'm gonna pull up an image and just, what do you notice? Maybe I'll pull it up.
Mhm.
There we go. So if anyone wants to throw anything in the chat, or if you want to just jump in and say something, feel free. Okay, so they're color coded, equal size changes. Yep. So these are Cuisenaire rods. I've created a set of Cuisenaire rods in Polypad, and the colors are intentional, and these are like, anytime you buy Cuisenaire rods, you're gonna find them in these colors. I had to change the white to a gray because otherwise it wouldn't show up on the screen. Cuisenaire rods have been around for a long time. In fact, they were the first commercially available math manipulatives. And so I think they've been available for sale since 1954. So they're celebrating their 70th anniversary. Cuisenaire rods were invented by George Cuisenaire, who was a Belgian music teacher. And his goal, his intention was to bring the joy that he saw with his students in music class into math class. So he wanted to create something that students could play with as they were learning math that kind of imitated the joy that he saw in his music classes, but that was missing from his math classes. And British mathematician Caleb Gaetano really popularized the use of Cuisenaire rods in the 1950s in classrooms. So this image is the first page of a PDF that's available on the Cuisenaire rod homepage or website. I've linked to it in our resources page, and so it's free to download. I downloaded this PDF and another PDF, and there are lots of great activities. In fact, in this document here, I got to a point where I was like, oh, I don't understand. I need to like come back to it and figure out like how they're using these Cuisenaire rods for multiplication, as well as addition, subtraction, and fractions and decimals. So the Cuisenaire rods they're not just for fractions. We can be using them for a multiple of things, including binomial distribution, which was something new to me. And so I'm hoping to explore that a little bit.
And including whole numbers. And I want to just jump back to the what do you notice thing just really quickly, just to talk about when I initially bring Cuisenaire rods into a classroom, because often teachers have never used them before, kids often have never seen them. And so it's really important to, I think with all manipulatives, give kids some playtime. And with older students, I say, yes, you're having playtime for 3 minutes, but while you're playing, I want you to think like a mathematician. So think about the relationships that you might find between the rods. Maybe you can name the rods with the value. And so always, by the end of that 3 minutes, students have given the rods a value. And some of them might just say, well, the white one is 1. If they've worked with decimals, they might name it the 10th. And so they always stack them in order. They just do it on their own because you always have those creative kids in class. And so after the 3 minutes, and literally that's all I give them, we have that conversation. I ask them to tell me what they discovered. And so a lot of those ideas about the rods just come out in that quick conversation initially. I know Carol Fullerton talks about making sure that kids know all of the values of the rods before you do anything else, but I haven't found that's necessary. Kids just naturally, when they don't know, they figure it out, and that's what we want them to do.
And it's really helpful when you're exploring and figuring out how to make use of these materials in your own classes to have a set at hand. So
Yeah.
during the spring break, I had my set of Cuisinart rods and I just played, and I couldn't, like, a lot of the things that I was trying to do, I couldn't do it unless I was playing with the rods. Like, I needed to physically manipulate them. I couldn't necessarily think about it and try to imagine what was going to happen. I needed to move the rods, and that was a large part of my learning and understanding.
Yeah,
And
and the magnetic ones are very helpful. You can buy them on Amazon because often before I had those, I was going around and picking up kids' models of things they're trying to show, and I'm like, it's just not as easy. It's way easier if you can just build what they're talking about on the whiteboard so everyone can see. Or use Polypad.
or yeah. So we've this first activity, I don't know, it's like 4:07. Do you think we're gonna have, do you want to throw it in? People could just maybe go
Yeah,
and look at it.
yeah.
I've created this activity in Polypad. These are questions that are coming from Carol Fullerton's book, Remarkable Cuisinart Rods, Mathematical Tasks for Primary Classrooms. So this would be K-3. She also has a book with a bunch of tasks for the grade 4-7 classroom. And if you are able to, like, again, you can't really do this question without having the rods at hand. And so we kind of assume that maybe you wouldn't have a set of Cuisinart rods like handy while you're sitting here listening to us talk. And so we've created this activity in Polypad. I can't
The
see,
link is in the chat.
yeah, if I think I'm just going to let you play with that if you want, or if you wanted to go back to that later and play. You can duplicate rods. It's pretty straightforward. I mean, at the very least, you might be able to figure out how to copy and paste in the same way that you would copy and paste in a document, but there is a little duplicate button, and so you can create as many of the rods as you want and just play around and see what that looks like. I would just maybe don't save the work that you do. I'm not sure what would happen if you do, but it probably doesn't matter anyway. So you have the link if you wanted to open it up and then go back and play a little bit later. But I think we'll run out of time if we talk too much about the specific tasks.
Yeah, this is really quickly just an example in a grade 7 French immersion classroom where I brought them in and I noticed right away some huge misconceptions that we cleared up within a couple of minutes of just a a talk all together. I find it helpful if kids can write, as I said before, the symbolic representation of what they're working with. And when I'm walking around, then that really helps me see what their thinking is and how to nudge them along. So yeah, this is the grade 4-7 book that Carol Fullerton has, and I use it all the time. Super simple. You literally open to the page and just say what it says to do. Easy, easy.
Yeah. Okay, and then here I've just organized. I think I'm going to skip through some of these slides. I mean, here's just what I did when I was making halves. The next question about how many ways to make the yellow rod, and you can move into looking at introducing that symbolic notation where we're naming each of these rods. So here our yellow is a whole, and each of the purple, the green, and the red and the white get named in relation to that whole. And then we can move forward even with starting some, like, again, we can be introducing this idea of adding fractions well ahead of grade 7, where we're just like, okay, we can count up how many of these fifths we have. And the rods help us to make those connections between connections to those number statements.
Yeah, it naturally just happens as they're creating.
Hmm. Oh, we've also, oh no, I'm jumping ahead of myself. Okay. So this is I found this task in on a on the New Zealand maths curriculum website, and they've got some great stuff. I would strongly recommend that you check out their stuff. So I've linked this particular task in the resources. I've also written up the task, and it will be included in the slides. And so, like, I just consider for a moment, I'll give you a bit of think time when I stop talking, the relationship between the blue rod and the green rod. And I am going to ask a couple of questions and ask that maybe, if you don't mind, throw in what you think, like throw in some numbers into the chat. So what happens if the blue rod, oh, I got is 1, what is the value of the dark green rod? So if we know that the whole is blue, Chris has thrown into the chat that the dark green rod is 2/3. So, okay, good. We're getting agreement on this. That's good. So then if we switch our frame of reference, and what if the dark green rod is 1? What's the value of the blue rod? Ooh, we have some dissent in our chat. Does anyone want to speak to this? Anyone want to defend the 4/3 versus 1.5? We're 2 for 2. We got 2 votes. Oh, the 1.5 is pulling ahead. I don't know if we'll get anyone to talk to it. It's always hard on these Zooms. I feel like I'm talking with you, Jen.
Yeah.
Okay. Well, I think so if our dark green rod is 1, so I purposely put the light green rods here so that we have another frame of reference. So if we look at our dark green rod, that takes up 2 of these light green rods. And so if that's the whole, the blue rod is a half bigger, like it's got one of those light green rods, which is half of the whole. So there's our 1.5. And this is like where we jump around and reframe our whole is a really tricky skill for students, but it's a really important part of the flexibility of their thinking with fractions. That we do this all the time, and a lot of times I think we do this without thinking. But this idea of like, okay, if this is a whole, what happens, but what if we switch it around and this is a whole? So being able to reframe our thinking from one unit to another unit is really important. And I would use this diagram as a way to start the discussion of, okay, what if we want to divide? Like, what if we want to divide 1 by 2/3? And so here we're coming to that frame of reference where the blue rod is 1 and the dark green rod is 2/3. How many how many 2/3 can we fit into that blue rod? And we've got a full 1 plus a half a 1. And so 1 divided by 2/3 is 3/2. And same thing, we could do it with if we wanted to divide 2/3 by 1. We could also look at that. And so that conceptually really helps students to understand what's happening with this division process with fractions.
Can I say something else that I've noticed that helps too for the kids who just aren't getting it because they still need to like have that one-to-one correspondence? I talk about sushi and cutting up and sharing sushi because sometimes with the Cuisinart rods, they can't see the parts, but they can visualize like sushi. Everybody knows that. So anyway, having context always is helpful.
Okay, I think the next thing is another task, which again, Jen, if you don't mind, we have set this up in Polypad for you. So if you wanted to play around, just looking at the time, we don't have time to really talk too much about this task, but this is a Kathy Marks Carpan idea, right? The circle concept. And so
It comes right from her book.
you've got, I mean, and you can use this in so many different ways. Like in all of the research I've done over the last 2 months, this is the one thing that I see consistently in many different places. So the idea here is we've got the number 1, and we're defining 1 to be 1 orange and 2 whites. And so can you then go through all of those other fractions and mixed numbers and use the Cuisinart rods to represent each of those values around the circle? And so we did set that up as a polypad activity if you wanted to play around with that.
I highly recommend that you do this on your own because I've used this in many workshops with teachers, and many adults struggle with this. So yeah, it's a great activity. And so I've accidentally just put the orange rod as 1 with kids a couple of times, and then they go to build a third, and then they're like, wait, I can't. But then it just turns into this great conversation of, why can't you? What could you do if you were, could cut up the blocks or whatever?
Here's another task that I found in this New Zealand resource online. And so to build a number line with orange is 2/3 and blue is 3/5. And you would give them some directions, like you want to include the numbers 0 and 1, some pretty obvious benchmarks, and then any other fractions that you can find. And so again, I did some playing over the break, and luckily I had some 1 centimeter grid paper. So that fit like when I was looking at this picture last night as I was prepping for our presentation today, and realized that in the picture some of my rods had moved over, but I was able to create this number line with all of these different fractions, just using these 5 colors of the Cuisinart rods. And it was really interesting. Like there's so many of those core concepts come out in this activity. Like, oh, can we find unit fractions? So can we find, like, if the orange is 2/3, is a student able to find the 1/3? And then can they count by unit fractions? So can they combine these unit fractions and count over till they get to 4/3 on their number line, or the 5/9 or the 9/5 on the number line by adding more of the fifths. So they are working on the decomposing of fractions into unit fractions, and then also taking those unit fractions and counting by unit fractions to find more fractions. You can ask students if they can find any other fractions, like, can you find 4/5? Can you find 3/15? So could we then take our fifths and our thirds, and can we figure out, oh, can we divide this into 15ths? And so we're talking about the partitioning of unit fractions into smaller unit fractions. And as you start to build this number line, like if I went back to the previous one that only had the 0, the 2/3, the 3/5, and the 1 on the number line, you can see this idea of the density of fractions is being illustrated through this number line activity, because we can always make some more fractions in between other fractions. And that's one of the things that's really challenging to move from whole numbers into fractions, is that there is no density of whole numbers. There's no number between 1 and 2, but there's an infinite number of fractions between 1 and 2. In fact, like there are more numbers, including fractions, like rational numbers and irrational numbers between 0 and 1, than there are whole numbers. And like, kids love talking about those abstract concepts, even at a really young age, and this idea of infinity. But that here's where we see that density of fractions kind of popping up. And I think
and the concrete supporting the symbolic for those kids who aren't ready just to work only symbolically.
And then at some point, as I was working through this activity, I was like, oh, right, okay, so here I do need to, I needed to move away from the concrete, because I couldn't break up my blocks any smaller. And so I think I wanted to get, I didn't have the right size blocks. I couldn't do the 1/9 or the 1/6, but I was able to estimate. So again, like estimating fractions, that's one of those really early core concepts, except that the idea of the core concepts is not a linear idea, that we are always circling back, and lots of these activities that we might do later on still rely on those early core concepts. So I needed to estimate, oh, can I estimate where 1/6 is here on this line, making use of what I've figured out with the rest of it. It was kind of an engaging activity, that I was super happy that I had 1 centimeter grid paper handy, and that I had my Cuisinart rods, because I couldn't have done that without either. So it's just that, that real intentional availability of materials is like helpful. Like if I didn't have the grid paper that was the right size, I couldn't have done this task. And so our students wouldn't be able to do it either. And so, you know, just making sure you've got the things that they need at hand, I suppose.
This is just an example from one of my classrooms where that idea of a stacked number line just naturally came up during a math talk when this teacher kind of jumped up and was like, okay, let's just look at this visually, like look at the number line, let's start playing around with these numbers. And yeah, so super powerful to help kids build understanding.
Yeah, and you've got like we can compare fractions here. We can look at these equivalent fractions and see how they and you can easily see whether they understand that idea, because do they have the 3/4 and the 6/8 in the same place? You can be looking to see if they understand all the different ways that they might be representing a whole and that they're all in the same place, that presumably we can't see over far enough in this picture, or maybe you can, maybe I'm not looking. Oh yeah, you've got the 1 and the 4/4. And maybe further down, they might have had the 8/8 as well. And so that they start to see that connection. Like I think I said this in the last session, that it is like, I would say half of my students in grade 9, if I ask them the question point blank, what is 8 divided by 8 equal to? They'll say 0. They don't say 1. And so just building that connection between the value of 1 and the 8/8 is like as along the way is really important. Here we have got another stacked number line. I've just divided the top number line into fourths and the bottom into fifths. And I think I mentioned like comparing fractions and how important it is for students to see there are other ways of comparing fractions than common denominators. So I can easily place the fraction 5/4 on my number line. And I can do this even without grid paper fairly accurately. I would say most students would be able to draw well, I don't know, maybe not. I think with some practice, you could draw a number line from 0 to 2 and divide it into fourths. That's probably easier than dividing it into fifths. But that they might start to see that, oh, right, 1/5 is going to have to be smaller than 1/4 because I need 5 of these. But they may need some practice with drawing a number line and partitioning. And that's, again, really important that the students have that opportunity to do that partitioning themselves, that we're not doing it for them. So if I was asking them to compare two fractions, I wouldn't give them a already partitioned number line in the same way that you're seeing here. I might give them benchmarks of 0, 1, and 2, but I would want them to practice partitioning. But if we want to compare the 5/4 to the 6/5, don't need to do common denominators, don't need common numerators. I can simply just compare where these two dots appear on our number line. And so, oh gosh, moving into this idea of number lines, like if my students all had number lines as a strategy to think about number when they hit grade 9 or even grade 10, I think that they would be like really flexible in their thinking, that many students show up and they don't have an understanding. And I just like, I make use of number lines all the time. And so just really important to make use of this from really early ages and then just continue on with it. So here, okay, here's a question for you. What number statement do you see? And I think we're getting pretty close to the end here. And so we might, I don't know. Does
Yeah,
anyone
5 minutes.
throw in a number statement for this particular image? Okay, 2/3 times 9. Okay. And it is hard to type fractions, so I'm gonna
Yeah.
move next slide here. And so I have used this image with other groups, and some of the statements that came up were like thinking about repeated addition. Whoops, I'm on the wrong screen, where you're adding 2/3 to itself to get 9. or to get 6, and you've done that 9 times, but that's pretty similar to our 9 groups of 2/3. Oh, wait a minute. Is this 2/3 times 9? Yes. 2/3 times 9. Yes, 2/3 times 9. I see this as 9 groups of 2/3, so I see this as 9 times 2/3. I also see this as how many 2/3 are there in 9. This was my original intention with this diagram, that we could use this to illustrate division. That if I want to know how many groups of 2/3 there are, or sorry, in 6, how many 2/3 are in 6, we can then count and see that there's 9 groups of 2/3 in 6. When I think of when I think of 2/3 times 9 from like an earlier perspective of multiplication, like what is 2/3 of 9? I actually see a different picture. I see 2/3 of 9 as being slightly different than 9 groups of 2/3.
Yeah.
And so we know that 2/3 times 9 and 9 times 2/3 is the same. We have the same result. We understand that the multiplication order doesn't matter. We have the commutative property of multiplication, but sometimes some of these representations tell different stories. So 2/3 of 9 is a different story than 9 groups of 2/3. And so we kind of miss some of those distinctions if we are strictly looking at fractions from a symbolic representation. What else do we got? Do we want to kind of swing through the next section kind of quickly? It's almost 4:30 now.
Or we can start with it next time.
We could. We skip ahead.
Sure.
So really the next piece was we were going to be talking about the area model. I had to try to figure out how to go back and, oh, I want to stop. Do I want to stop sharing? I don't really want to stop sharing, but I want to, there, that's what I want to do. So I think it's probably nice to share this screen.
Yeah, that's
So
a good ending.
yeah, okay. So coming from John Vanderwall, really that we want students to have the opportunity to be mathematicians, and that using all of these different models is going to give them an opportunity to play and explore.
Yeah, that came, I pulled that one when I was looking for something about using materials. Materials or manipulatives allow for the doing of mathematics. But visuals do too, especially if we use Polypad.
Yes, Polypad is great. Speaking of Polypad, just another plug for our fall conference. David Porras, who is really the head guy at Polypad, he does all of the creation stuff. I mean, I'm sure he's got a team working for him, but he will be he's one of our featured speakers as well at the fall conference, and we'll be doing a workshop on the Thursday afternoon. Actually, I think Marion Small is doing a workshop on Thursday afternoon as well. And so we have lots of fun stuff to share with you at the fall conference. And I'll just kind of take us through. We can add, maybe before we share, we'll add to our resource page and put a few of the other things that we talked about. This was the number line activity, so I've included that. And that's it. We hope to see many of you here again on Wednesday, May the 8th, where we might start with modeling with the area model. We'll see. Or maybe just focus on assessment of fraction understanding through tasks. We can build some area model into that.
Perfect. Thanks for coming, everyone. Thank you for being here. See you soon.
Okay, I'm going to stop sharing and stop recording. How do I stop recording?